Good morning to everyone present here. This is Dheeraj, pursuing a Bachelor's of Technology in Civil Department, and I am from C2 class as well. So I'd like to give my technical seminar now. Slide please. Next slide. Right. Concrete is uniquely positioned to respond to one of the most rapidly growing trends in today's construction. So concrete, I need not define concrete to you because it's all very much familiar to us. So it is uniquely positioned to one of the rapidly growing trends. Let us look at what trends is that. What trend is that? So embodied carbon challenge. What is embodied carbon? So the carbon dioxide emission that takes place during the entire process of construction is called as embodied carbon. Let me again define it. So the construction process takes place, and during the process of construction, carbon dioxide will be emitted out into the atmosphere. So that will be emitted out from the cement and from all the materials, and during the construction and even after the construction also. The carbon dioxide that is emitted only during the process of construction, from the beginning till the transport or everything under the construction. The carbon dioxide emitted during that span is called as embodied carbon. It can also be defined as the carbon footprint of a building. Now let me define what carbon footprint is. As the name suggests, that is the print of carbon that we are generating. In other words, so we will be doing our daily activities like consumption of food, production of food, and we travel on bikes, and we burn fossil fuels. We cook. During all this process, what happens is we emit greenhouse gases into the atmosphere. I need not again introduce you what greenhouse gases is. Greenhouse gases are carbon dioxide, ozone, nitrous oxide, chlorofluorocarbons, HFCs. All these gases are greenhouse gases. The greenhouse gases that are generated by our actions is called as carbon footprint. So when we perform our activities daily, we'll be emitting GHGs into the atmosphere, and that is the carbon footprint associated to us, because we emit those GHGs. And in the similar way, the carbon footprint of building materials and construction. So that means the carbon dioxide that is emitted from the building materials and the whole construction process is called as embodied carbon. So right. Next topic please. So what is carbon capture? So you must have by now understood. So this embodied carbon has a negative impact on our atmosphere because of the emission of carbon dioxide. We know that the temperature of our planet will be growing, will be increasing. So this is what we call as global warming also. Because of the global warming, we know that there are a lot of negative impacts. As the temperature goes on increasing, we know that in Antarctica, the icebergs will be melting, and methane gas, which is trapped under the ice, will be coming into the atmosphere, due to which there will be an increase in the temperature again. And when there is increase in temperature again, and the water bodies, the water will be rapidly evaporated, and then there will be increase in the temperature due to that also. This is not, I'm not gonna get deeper into that because I'm not much familiar with it, I don't know it either, and that is not our topic. So we know that this embodied carbon has a negative impact on the global warming. The temperature, as it increases, it has a negative impact on us. So in order to counter-react to the embodied carbon, we have come up with a cure known as the carbon cure, which is today's topic of mine, carbon cure technology. As the name itself suggests, this is a cure. This is a cure to what? This is a cure to carbon. Embodied. This is a cure to embodied carbon, to minimize the amount of embodied carbon that we emit into the atmosphere. How do we cure the carbon? We use carbon to cure the embodied carbon. How is that possible? In order to minimize the carbon, we are using the carbon. I'll tell you how. So this is a carbon cure technology. is a very simple process. It's a single step process, but very effective. So what is done in this process is we inject carbon dioxide into the concrete mix while it is being manufactured in the concrete plants. And then when the carbon dioxide is injected, the concrete that is produced will have much compressive strength compared to that of normal production. When there is more compressive strength, this means that the concrete required, I mean the cement required the production for the production of concrete will be reduced. That means the cement, when the cement is required in lesser quantity, this means that the cost, the method has become economical. So when it's economical, this thing will be rapidly used and there will be business growth. So I'll tell about the whole process in detail. Next slide, please. CO2 supply. Let's get into the process very deeply. Firstly, I've told in order to counter-react to the embodied carbon, we will inject carbon dioxide into the embodied carbon. So, how? CO2, we know that a lot of industries produce carbon dioxide as a waste, because carbon dioxide is emitted into the atmosphere, and that is causing the global warming in some way or the other. So that carbon dioxide, which is a waste from the industries, will be collected by industrial gas suppliers. They'll collect the carbon dioxide, and that then will be purified. They'll purify that carbon dioxide and they'll liquefy. The carbon dioxide will be converted into the liquid form, and then it will be delivered to the concrete plants. Into the concrete plants where the CCT technology, I mean the carbon cure technology is being used. That will be delivered there, and it will be stored in storage tanks. There will be pressure. The carbon dioxide will be pressurized and it will be in the liquid form. Next slide, please. How it works. Let's look at how the technology works. This basically works with the 3I principle: installation, integration, and injection. So the carbon cure technology basically consists of two components. One is the control box and the wall box. The control box is placed at this. Control box is this. That is placed at the batching software of the concrete plant. What is batching? So grouping a particular task is called as batching. So now you must be familiar. We'll be watching Discovery, right? Before we came here, we used to watch Discovery, and we used to watch some how things are produced, food items or whatever it is, how they are produced. So lot of machinery will be doing the procedure, not men, not humans. So all the tasks that are performed by those machines are sequentially performed. So there's a proper sequence and the proper tasking that will be very organizedly done. So that is called as the batching software. For every concrete plant, for every industry, there will be batching software, which means this thing will happen first, and then this, and then this, and then this. A particular sequence of tasking will be there. So with that batching software, these both will be installed, which the control box of the carbon cure technology will be installed with the batching software seamlessly. That means to the batching software, to the sequences of tasks that are gonna be performed by that concrete plant, to that this carbon cure software will be added, will be integrated with that, and there will be no wastage of time during this. Okay? So there will be no wastage of time in the production of concrete, nor the building construction. So there's no effect in time. And the wall box. And the wall box is connected to the storage tanks that I've shown you previously. The storage tanks which contain liquid carbon dioxide. To that box, to that thing, storage tank, wall box will be connected, and to the wall box we'll have ready mixed concrete, where the concrete is being mixed. Where the concrete is being mixed from the wall box, there's already liquefied carbon dioxide in the storage tank. From there it will be transferred to the RMC via the wall box. So what happens? Injection of carbon dioxide. The liquefied carbon dioxide from the storage tank will be converted into solid and gaseous form while it is being injected into the RMC. How will that happen? Means when it is passing through the wall box, there will be a rapid decline in the pressure. Due to the rapid decline in the pressure, the liquid state of the carbon dioxide will turn into solid and gaseous state. To be more precise, we can say it is in the form of dry ice or like snow. It turns into snow. It's snow. What happens when this exactly looks like this? It's not clear here. they look like much like snow. So what happens? These are some chemical reactions. When carbon dioxide is introduced into the RMC, there will be some chemical reactions. What happens is cement, the cement in the RMC will react with the water to form calcium ions, and the carbon dioxide that just went in, will react with water to form carbonate ions. These carbonate ions, on reaction with the calcium ions, will form calcium carbonate, also called as solid limestone. We usually call it CaCO3 also. That one only. This is a reverse calcination process, because we know what calcination reaction is. On the combustion of CaCO3, calcium carbonate, we get calcium oxide and carbon dioxide will be emitted. So this process is the exact opposite to that, because we are converting carbon dioxide into calcium carbonate here. So this is a reverse calcination process. Converting CO2 to ammonia. Now, after the carbon dioxide is converted into calcium carbonate, what happens is 0.2% of the cement in the mix RMC will be converted into a nanomaterial, into a nanoparticle, very small in size, specifically in the range of 400 nanometers. And all the other 99.8% of cement will be normally hydrated. It forms as normal concrete. What happens is this 0.2% of the nanomaterial that is formed will form a surface on the concrete layer. And what this does is it increases the compressive strength of the concrete. Compressive strength of the concrete. That means, what is compressive strength? If we have a slab of concrete of this much thickness made normally, and we have this much of concrete slab made with CCT, so both of these will have the same strength. So what happening here is, if the strength is more, will reduce the amount of cement. Will reduce the amount of cement. And cement, when the amount of cement is reduced, there will automatically be a decline in the amount of embodied carbon, right? Because cement is one of the major reason for the global warming. Cement, it actually releases 7% of the carbon dioxide into the globe. All the carbon dioxide emissions, it constitutes 7% of it. Next slide. So compressive strength effect. This thing here is the concrete made normally, and this thing here shows us the concrete made with CCT technology. You can see that there is increase in the compressive strength. That will be improved. Next. And mix optimization opportunities. Now, this is the concrete that is made under normal conditions, and this is the concrete that is made with 5% less, 5% reduction of cement. So when there is the reduction of cement, the strength, compressive strength is in PSI, pounds per square inch. The compressive strength of the concrete is decreasing. But when we use CCT with the reduced cement, it is again gaining that strength. So that means the amount of cement that is required is reducing. And we can also say that it is statistically proven that 3 to 7% of compressive strength is gained by using CCT. Next slide, please. I need to hurry. Okay, and this thing, injection of CO2 has a neutral impact on concrete fresh properties and hardened properties. All the other properties of concrete, like hardening, like pH, setting of the concrete, hydration, air content, temperature, texture, all these properties will not be affected. So there's no kind of negative impact on it. And durability evaluation. So by the tests performed by these men, US State Department of Transportation, concrete producer verification, third party concrete consultants, by all the after they have tested CCT, it is proven that the durability testing showed that the CO2 injection process has a neutral to positive effect on the concrete durability. That means the concrete that is made with CCT has a neutral to positive effect on the concrete durability. That means in the worst case scenario, the concrete that is produced with CCT will have no impact on the durability. That means even when it is done normally, and in the worst case with CCT, they will both have the same duration. But most of the cases will have that it has a positive effect on durability. So that means we have an increase in compressive strength. We have it takes lesser time, it becomes economical, and it is also being durable. Now, carbon cure impact. Now, what happens with this is, let me give some statistics. If we use the carbon cure technology while manufacturing concrete, for 1 cubic meter of concrete produced, it saves 17 kg of carbon dioxide emitted into the atmosphere. That means we can save that much of carbon dioxide by using CCT. And while constructing a high-rise building, say any skyscraper, if it is constructed using the CCT, that will reduce 80,000 kg of carbon dioxide. So that's a very big number. So this technology is very useful, and these are few projects that are constructed using the CCT. In Atlanta, this is McDonald's building, LinkedIn campus, Infosys Innovation Hub, which is in Indianapolis. And some building is also in Illinois, I think. Next slide, please. Okay, these are all the effects that CCT has on the production of concrete. All the effects that it has are all positive. The compressive strength is increasing. The embodied carbon will be reduced. I need to mention this. After the using CCT, after the injection of carbon dioxide is done, it is converted into calcium carbonate. Right? So there is no carbon dioxide. That means there is no emission of carbon dioxide into the atmosphere. That means there won't be any embodied carbon if it is manufactured using CCT. So if there is no embodied carbon, that is very much better to our atmosphere. So these are all the effects. It has a little bit of disadvantages that include we must inject CO2 very precisely. The amount of CO2 must be very precise. That is exactly 1 pound accurately, 1 pound per a yard of concrete. 1 pound in kgs means at 0.454 kgs, I think. So that much of carbon dioxide should be exactly injected into the mix. That will be exactly done by CCT. That's not an issue. But the concrete mix should not be hardened while this is being injected. That must be exactly injected at the time while it's being injected. These are very few disadvantages. And with this, I'd like to wrap my presentation. I'd like to thank Sneha ma'am and Anusha ma'am for giving us this opportunity. I'd like to thank you all for being so patient and attentive to me.
Thank you.
Thank you.